moving to the cloud was easy. It was a one-click promise of infinite scale. But as those monthly bills grow and data laws tighten up, many businesses are realizing that someone else's computer is becoming a very expensive roommate. I'm Bill Shoughton, and this is the SUDO Show, where business meets Linux. Today, we're talking about the Great Cloud Breakup. We're exploring why top-tier engineering teams are pulling out their data of the hyperscalers and moving back to hardware they actually own. It's not a step backward, really. It's more towards control. But first, Neal and Noel, how are you guys doing?
Doing great, Bill. How about you?
Yeah, fantastic as always.
I've had a crazy day moving VLANs around at a client, so all I see are subnets and IPs in my head. So I'm very happy to be here.
All in on networking today, right?
I'm all in on networking because somebody filled up a subnet that didn't need to be filled up and shouldn't have been filled up and caused a lot of unnecessary problems. So if I start speaking randomly in IP addresses, then just like push me out of the studio and we'll go on from there.
To be clear, we're talking IPv4 addresses because I don't know how it's possible to fill up a v6 address allocation.
To all of our listeners out there, if I start speaking in IPv6 addresses, please send help. That requires a professional diagnosis.
Oh my gosh, that is I need to hear the story about that someday.
No, that's something we'll never talk about because I'm not going to let myself get there. I have a wonderful support group of friends and family who prevent me from ever entering that dark space. I can see the cliff and I say, no, I'm not going over that cliff. I will not speak in IPv6 addresses. Not yet. But however, first, we need to check the status of the ecosystem. It is time for the stand-up.
Well, one of the big things that's been happening lately is that, like, in concert with a lot of the stuff that's been shifting around with data protection laws, like California's got theirs, and Washington State and New York State are both working on theirs. It's sweeping the U.S. Canada's got their data protection stuff in place. The EU and the UK both have doing it as well, and I know that there's stuff going on in Asia around this as well. Like, lots of these laws are actually coming into effect now. So,
what laws are we seeing coming into the
system?
So
I believe the EU Parliament's directives around data protection and data residency. It's not data protection. That happened years ago. Data residency laws, which are essentially saying that if you are a member of an EU nation, your data storage primacy must remain in there. And then there's other extra conditions and stuff like that and agreements and whatever. The particulars aren't super important for our purposes, but what is important is that customer data, user data, and let's be very general here, user data of any kind cannot leave without notification or process or correct modeling, cannot leave the jurisdiction it was created in. And sometimes it can be stricter than that. Sometimes it can be less strict than that. But I think from a general business modeling perspective, it's wherever that person comes from, you got to assume that the data that is initiated for that person has to stay where it was created. And if there's a reason that it needs to move, there has to be processes in place to handle that as an extraordinary event rather than an ordinary event. And as this keeps on happening, and it's, again, the European Union's got their thing, and that means that the individual member nations of the EU 27 are going to be ratifying and codifying them into laws over the coming months as their individual parliamentary sessions go into effect, or go into session, and they go and do stuff, and their laws go into effect, whatever. And then the UK's done their own thing as well. Ofcom and all the others have put in their recommendations, and that's happening now. The US states are all looking at this as well. You're going to see a shift in which data now has geopolitical boundaries. And that is going to change the way that you think about everything. Consequently, and maybe not consequently, but as part of maybe a confluence of coincidences, the major cloud providers, your AWSs, your GCPs, your your OCIs. For those of you nerds out there, I'm referring to Oracle Cloud, not open containers. Why they're both OCI is beyond my comprehension. And Azure have all started updating their exit fees. This came as a result of a couple of years back where there was one of the cloud providers started promoting that they made it super easy for them to leave their cloud as a way to get people to come onto their cloud, and all the other ones kind of followed suit as a competitive measure. Well, they update those regularly. Those fees and the structures and the policies and how to execute them change on a regular basis. So be mindful of those things, but they have now been refreshed. And as you are looking at what you want to do for your footprint, whether that's in the cloud or on premises or both, right? You're this is something to factor into. And so start thinking about it before those things take effect and affect you. Like most companies out there, they do their budgetary planning, hopefully aligned to the calendar year and not the government fiscal year. But some of you do it on one or the other. If you're on government fiscal year, you got to figure it all out before your Q4. If you're on calendar year, you got to do it before your Q3.
Now, are we as a Linux community ready technically for this kind of migration? Do we have the throughput in storage to handle this? I mean, bandwidth is obviously much better than it used to be, probably when people started moving data to the cloud.
Mm-hmm.
But high-speed internet doesn't necessarily mean a 300 meg cable connection anymore. High-speed internet, oftentimes referred to as gig plus fiber.
Mm-hmm.
But all of us know that storage and storage networks doesn't necessarily keep up with that speed. So have there been any improvements, enhancements to the Linux ecosystem to help facilitate this and make it faster? Because it sounds like some people are going to be in a tight deadline.
Yeah, I mean, there's definitely some of the NVMe stuff that's been like NVMe over networking, or otherwise known as NVMe-OF, NVMe over Fabrics. There's a lot of new stuff coming in for the 6.19, 618, 619. The 618, I think, was the latest LTS kernel for those distributions that follow that mechanism. If you are using, for example, Red Hat Enterprise Linux or SUSE Linux, where they don't actually follow the LTSs, they do their own kernel management, you're going to probably start seeing those things come into play in their spring releases. So, like, for example, if you are Red Hat Enterprise Linux, you'll probably see some of this trickle in with Red Hat Enterprise Linux 10.2 and 9.8. 9.8, yes. And for SUSE Linux, you're going to see this with SUSE Linux with SUSE Linux 16.1 in the fall. It might actually already be in 16.0 now since it released so late. You're going to see that a lot of this stuff is going to hit you for the first time, and it will give you tremendous speed ups across your storage stack. Now, again, the core block storage stuff, NVMe-OF, is not enough. You've got to actually have optimizations in scheduling and memory management. You have to have other things in place. Make sure you know what you're doing for your workloads. But you can have on-premise network storage latency be no different than your local bus speeds, especially if, even on the very, very low end, if you're doing 10 gig, right? We're not even talking anything crazy like 25 gig InfiniBand or any of those other things. We're just talking straight up, plain, twisted pair, 10 gig Ethernet. You can probably, at the very minimum, achieve roughly about half the speed of the internal bus, but half the throughput of the internal bus, but you'll have the same latency as the internal bus. And that's the key part, because again, you're still downloading from the internet, you're still constrained by the internet bandwidth. So if you are half the speed of the internal bus, which, by the way, for NVMe PCIe Gen 4, let's say that's what you're working with, you're still talking about 4 gigabits per second, 4 to 5 gigabits per second, which means you're easily talking, it's like, I want to say like 500 megabytes a second, something like that.
So wait a minute. You mean to tell me that my ATA 100 10 gig Mac Store hard drive that I wired all the pins into a 25 pin to console cable adapter off the IDE bus, then plugged it into my modem and get dial up is not going to work well. I put a lot of effort into that contraption and now I feel a little deflated.
I'm impressed. But
it's just wires. They should work.
I mean, I'm just impressed.
I think you need to demo that on one of like maybe our live shows or something like that if we ever end up having one. Because
I did the same thing with a PoE adapter. I just lopped off one side of a power cable and one side of an Ethernet cable, and I soldered 4 pins and then or 3 pins, 3 pins, 2 to the ground, and that way I had double the grounding. So that's my electronics expertise when it comes to DIY data repatriation. So I think, Noel, you probably have some experience doing this more professionally than my butchery of cables and drives. Have you encountered any of this yet in your day-to-day?
Like the data repatriation thing is really, really interesting. And I think one of the reasons, and like kind of a small plug for what Red Hat does, but the reason why they developed OpenShift is for the capability of having a common platform that can exist basically either in your on-premises data center or in the cloud. And so really the main thing is keeping in mind is the fact that because you have this common platform, it does allow you to basically, have your data live wherever it needs to live. And so I think for our perspective, like I feel like Red Hat is very ready for customers that are interested, like depending on the scale of the customer, of course. Like if we're talking about like small business, unfortunately, I'm going to say that OpenShift isn't the greatest solution for this. But like I do think that at least at the large scales that we're talking, with cloud vendors and stuff like that, and these large data repatriation efforts when it comes to like governments or businesses and that sort of thing that are operating at that scale, it's really good to try to not lock yourself in to a vendor lock-in in the sense of like, because again, OpenShift, for all intents and purposes, like it has a lot of fancy, it's Kubernetes with a fancy hat, basically. Like it has a bunch of
somewhat literally a fancy hat, isn't it?
Yeah, literally a fancy hat, exactly. So I do think, like, from my perspective, like I'm really excited to see that companies are interested in having that ownership, because like some of the experiences that I've had in my career have been literal lift and shifts from on premises to the cloud. And like the cloud is great and it's awesome in certain areas, and in other areas it's like if you're literally just running a bunch of VMs the way that you do on premise, it's literally just going to cost you an arm and a leg more because of the fact that the cloud provider has to have some way that they make any kind of money. The benefit that you have with the cloud is the scale of being able to spin up and spin down, workloads that exist ephemerally, in the sense that you don't want these machines to be running all the time, or you want to be taking advantage of pricing in regards to certain services or things that they offer. I think that's like kind of one of the more interesting concepts that we're running into right now, is the fact that it's like, as hardware costs and things go up, as things in the industry are going on, it's like always this balancing act of like, how are you getting the most bang for your buck in however you are doing this, whether it's on premises or in the cloud.
Yeah, I mean, I think that it would be when you think about like how you want to have a private cloud platform. The important thing is to figure out your private cloud fabric, right? And so
Mhm.
that can be OpenShift, or if you want to use the community version, you can use OKD.
Mhm.
Um, or if on the Rancher side, right, like another very popular platform with a different structure and set of tools and features that is also very interesting is the Rancher stuff from the folks at SUSE. They've got this Rancher Prime platform, which includes the ability to do things with the Rancher Suite, which includes not only the container orchestration stuff but virtualization, security modeling, common network fabric setup. storage setup, the whole works, right? Whether you go with the OpenShift OKD or you go with the SUSE Rancher suite, right? You're going to have essentially a comparable base layer to start from to build your own independent experience for your needs to run your business with your own cloud infrastructure.
So let me ask you guys this. In the past couple of episodes, we've talked about careers in open source. We've talked about how you start, where you can grow into. Let's fold that into this then. Where are the future jobs? Because 5-6 years ago, maybe a little bit more, everybody's ideal job was cloud engineer. But if data is being repatriated back to on-prem, whether it's files, databases, applications, websites, whatever have you, is that cloud certification transferable back to an on-prem environment? Have we managed to equal the toolkits between what's in cloud and what's on-prem to where those skills are transferable? Or do you find that we're going to go back to storage administrators and network administrators and system administrators and all of the things that we had before?
Yeah, you're going to go back to that for the simple reason that when you are operating in as a quote unquote cloud engineer, and I'm going to say this as you're referring to interfacing with the public cloud provider and using their tools, right? I'm going to reclassify them as cloud API engineer because that's what they actually are. They learn the APIs, they use the tools that are provided as the abstraction layer that cloud provider has that is unique to them. And so when they're working with those things, they're not hitting the nuts and bolts. They don't actually understand how the platform is put together. They don't actually know what they're doing at a fundamental level when they're orchestrating the cloud components. They know how to put the solutions together. They know how to make things work, but they don't necessarily know the implications underneath all of it. So I think I have some relatively unique experience here because I made private clouds using OpenStack, which is also a valid solution path for this.
Yeah, I was gonna make the plug for OpenStack. We never talk about it anymore, but there are still large customers that use it, and that operates more like like what you would expect a cloud would operate, in the sense that you can run OpenShift on OpenStack.
I don't like this, Noel.
We will get there. We will get there in the main topic, but like kind of sum up this bit here, right?
Yep.
If you are repatriating, if you are, you know what? Not repatriating. If you're moving to your own infrastructure, you are no longer an API engineer. You are an infrastructure engineer, which means naturally what's going to happen is you're going to start needing more specialists who understand the functional concerns of the infrastructure, who can manage those aspects. So you're gonna see that pendulum swing back, and they may still be titled cloud engineers. Do not get me wrong, because they will probably still be called that because it's easy, but they will be those roles.
In my own experience, though, too, just to provide like a different, maybe not a counterpoint, but just like additional color to the conversation. Like the thing that I've noticed too is the fact that like this whole idea of a cloud engineer is a myth. Like the idea of saying like I'm a cloud engineer. Okay, what part of the cloud do you work on? Because if you say I'm a cloud engineer, does that mean that you work on the networking? Does that mean that you work on the the server portions? Does that mean you only work with those specific like products? Like there are specific fully hosted products like Neal was talking about where it's like interacting with an API and you're writing code to basically state what the infrastructure should look like and how it should be. Are you like there are, especially like in the smaller scale businesses that I've worked in that specifically use Azure, like they kind of think of it in the same way. Like customers will either fully embrace the cloud thing and like make it a completely like developer heavy set of people that both know how to develop, you know, code and also understand infrastructure, or they will have like the other side of the pendulum where it's like, network engineer, you now get to learn cloud. This is what you do now. Like, apply your skills that you already have to doing this thing, but it's in the cloud now. Like, that is kind of the two pendulums that I've seen in regards to like where companies will either successfully embrace the cloud or they won't. And so that's I think kind of the thing that I think about a little bit too, is that learning these skills for on premises, you know, learning how these products work, how these types of things work, that is more transferable skills. That knowledge is more transferable to the cloud than I would argue the other way, which is if you learn how all the abstraction stuff works, then you're like, oh, now I have to figure out, you know, like you're going to learn it at a high level, but you're not going to have that nitty gritty. Like, I was up until 2 a.m. working on VLANs and trying to figure out how this crap works. Like, it's so, yeah, it's a challenging thing. Like we said in the career episode, like, it's the more things that you can learn, obviously the better. But I think like I have had a very successful career with interacting with the cloud and not going so whole hog deep into that side of things and learning all of the APIs in and out. Like, I have an AWS certification, but I haven't used AWS in a while. Like, my use case is a little bit different because Red Hat and the customers I work with are focused on on-premise, but like it's kind of one of those things where it's like you kind of have to learn both.
And I think that's the answer I was looking for, was make sure that if you're a younger admin or doing a career change, that you keep your skill set balanced and don't just throw everything into that one buzzword, because at the end of the day, you're a generalist, whether you're a cloud generalist, an on-prem generalist, a network generalist, you still have to be a generalist. You still have to have those good fundamentals. So the consistent and steady answer I think we can all agree on here is continue to get your core certifications, because that's going to lay the foundation for everything else, even in this crazy world of data shifting back and forth between public cloud providers and on-prem.
And don't worry, Bill, all of our jobs are going to be gone by AI, according to all of the people in Silicon Valley. So, you know, like, don't even worry about it. It's fine.
Listen, okay, I have right here next to me a plastic fork, and this is my technician motivational tool model 100. It's portable, light, and disposable. An AI can't replace me sticking this into the eyes of a technician that has defied my orders. Lord Bill will still carry the plastic fork. It just happened to be next to me.
I think nothing can replace this rubber duck.
I want to know what that rubber duck tastes like with some orange sauce on it.
Oh,
no.
I don't know that would be very good.
No, I don't think that's a good idea.
Right. Neal's duck is off limits. Now, obviously, someone has built tooling and software to help with these kinds of migrations. So for this month's supporter spotlight, I thought it would be nice to highlight rclone and the work of a certain Nick Craig Wood, who has been the creator of rclone. Noel, tell us a little bit about what you know of rclone, because I think you've had some experience with this before.
Dude, rclone is awesome. Like, I cannot think of a tool that has been more useful for just a wide variety of different stuff that I've had to move data from one place to another. Like, the fact that it integrates with so many different, like, whether it's different providers like in the cloud, whether it's different types of, you know, storage, and everything like that, like, it is just such a Swiss Army knife when it comes to moving stuff around. Like, it's a tool that, like, literally is always in my back pocket. Like, it's in the list of, like, you know, like, I have this tool for this and this. This is like the tool that I use for moving stuff. Like, besides rsync, which is basically what it does, for all intents and purposes. Like, it's funny, like, even right now, a big, little bugbear of mine is that I really want to use Proton Drive. I've had it for, for forever. Like, I've been using Proton Mail. I looked at when I got it, and it was like back like 6-7 years ago. And they have Proton Drive, and I have all this storage, and I need to move it. rclone has had a Proton Drive way of interacting, and it's probably even better now because they have a proper API. But like, if I've wanted to move a bunch of stuff into Proton Drive, like, it has just worked. As far as I'm aware, I don't know if I haven't done it in a little bit, but like, it's kind of one of those things again, like, people have done really cheeky things too with rclone, where they like had like multiple different like Google Drives, where they basically like use rclone to automate moving their files into these free Google Drives and stuff. Not that I'm advocating for that. I'm just saying, like, people can do it. It's probably against the terms of service for Google. Don't do it. But like, it's just kind of one of those really cool tools that I think like is just incredible. It's really, really nice.
Well, in a previous workplace, I used a tool called Restic for doing, like, our company policy was that our laptops had to be backed up no matter where we were. We had Google Workspace accounts. We had infinite storage in the Google Workspace accounts because old Google accounts. That's how that worked. And we basically configured every Road Warrior computer to just automate backups into it for their user data. And you know what Restic uses in the backend to do that when you're going to Google Drive? It uses rclone. That's what it uses underneath it all. And so, like, yeah, I mean, rclone has become kind of a Swiss Army knife of being able to manipulate data across different data fabric models, whether it's FTP, Samba, or even different public clouds, or like S3 type stuff, or the various weird drive systems like Google Drive and OneDrive and Proton Drive and SharePoint and all these other things. Like, yes, it knows SharePoint too. How they know that is scary, but like, it can do SharePoint things.
Mm-hmm.
So like, it is super, super interesting and super useful. And Nick Craig Wood has been doing this for a very long time. He created it and then he maintains it, and he has a little business for it too. And so he commercially supports it for people who want to really rely on it as part of their core workflows. And I encourage you, if you're a user of rclone at scale in a business, to go check it out and go and see, support him and his work. Because without great people like him, you ain't gonna get great software like that.
You'll end up doing what I do, which is copying and pasting everything between floppy disks and DVD-RWs. Don't do what I do.
Dude, I had a customer that legitimately, they had a this was a long time ago. I do not know if they still do it this way, but
they probably still do it this
way.
Might.
They very well might, but there was literally a set of disks that he had a ZFS cluster on premise at his business. And he had a ZFS at home, which was the crazy part. His backup strategy was literally having a ZFS pool on premise at his business. And then he would drive over the state line to where his house was, and he'd bring all of these drives. Well, he would take all the drives out, he would replace them, and then take all of the drives back to his house and re-import everything, so that he basically had, because the transfer speed between the 2 points was too slow, so it was easier for him to just drive them there.
Sneaker net.
It was literal sneaker net. He would literally drive them back and forth. It was the craziest thing. I was like, this is so cool, but also like, holy shit. Like,
well, when I was working, a couple employers back at a major technology services company that specialized in backups. We don't say the name anymore because it's verboten. But like, one of the things that we actually did offer as a service was shipping you a computer that literally was just a giant drive that you downloaded to do SneakerNet replication. I mean, technically UPS replication, but like, basically, we did that because, 10 years ago, it was not common to have a low latency, high bandwidth connectivity in residences or offices. Like, my first job, the place I worked at, and that was in 2013, we had a T1 line, and the company leaders were so proud of the T1 line. I was like, can we get a T3 line? Like a T, because the executive would then go on a Skype call. Yes, Skype. This is how you know it's dated. And no one could do anything because all the bandwidth was gone.
Not Skype for Business, though.
No. Just plain Skype. Just regular Skype.
Okay, so I think the strangest one I ever had with a data move like that was in 2008. I was called into a customer to figure out some of their problems, as they said. And one of the problems was transferring files. So I went to one of the workstations and I said, okay, show me where you're having the issue. Show me where the server is. No server shortcut. Okay. Maybe it's some UNC path or something I missed, right? So after doing some investigation, I realized that the box that they considered to be the server had actually died, and so they weren't using it.
Oh.
So when they go to, I said, all right, but how are you transferring files? I'm looking around on everybody's PCs for some open file share. Nope. Bluetooth.
Oh.
Well, we saw that, we could transfer files over Bluetooth. So that's just easy, but we're having problems making it work. So after I had come back to consciousness, because I promptly fainted when I heard
Bluetooth. And this was 2008, right? You said Bluetooth.
This was 2008. And it was,
oh my gosh,
that means Bluetooth 10 people, and therefore they were using Bluetooth. And one of the complaints,
but that means Bluetooth was dial-up speeds back then.
Yes,
it was not fast, and it's still not fast.
I questioned why they didn't even just have like a router and a couple of computers and networks. And the answer that I got was, well, I read that it would work on the internet, so I did it.
Yeah, well, it is technically a way you can move data.
Does not mean you should. Just because you can.
It is technically a path. People, it is what QuickShare is done with, but
I'm gonna ask Nick, actually, if we ever meet him, Nick Craig Wood, that he can make sure that rclone supports transferring files over Bluetooth.
Oh my gosh.
Nick, if you hear this, know that your colleague Noel here would like to implement a feature request of Bluetooth. And I advise that you write and create this for a release date of April 1st, 2026.
Yes. There we go.
You heard it here first, folks. We are going to do a public cloud repatriation tool on April Fool's Day using Bluetooth.
Oh my gosh.
But it's better than Pigeons. Is it better than Pigeons, though?
No, because Pigeons have a higher bandwidth, even if it's a lower latency. Pigeons would be better because you could give them a thumbstick with more data.
That's true.
I mean, if you can afford a thumbstick, you can put a thumbstick on and clip it to them, like how they did the old glass of text.
Or even like a more NVMe in an enclosure,
It would be more throughput. More throughput, even if it would take forever.
That's true. There is an RFC written for it, so that's the other feature request, is making sure that rclone
IP over
works.
avian carriers. I can't believe I remembered the formal name for this, but yes, there you go.
And nowadays, too, if you think about it, it is technically object storage and transfer. Because the Pigeon is picking up the drive, which is the object, and transferring it into storage. So does that count? Is that what object storage is?
This segment is so unhinged.
But I have used Restic before to transfer files between, even in small businesses, I've used it to transfer data between weird dissimilar situations. I've had a place that one department kept everything in Dropbox. This other department hated Dropbox, so they used Google Drive. And then another one used SharePoint. And
no, I've been there. That sucks.
It's not a great way to work. And they were also trying to deal with CAD files
They're
proprietary
doing tag files across 3 different file lockers?
because everybody had their own way of doing things. And so I was brought in to help standardize that. We deployed.
So they made you be the bad guy for them.
They made me be the bad guy, but that's okay.
No. That's like no. This is what I'm making it clear to the people on the internet. Sometimes you are going to be hired specifically to be the bad guy.
Oh, yes.
And you should own up to it.
Yeah, and I fully own it. I walked in there and said, nobody's going to like me for quite some time, but you will when we're done. And where I was able to use Restic was connect. I took a small leftover machine. I just simply installed Linux on it, put Restic on it. The other endpoint was actually Synology NAS.
Yeah.
So I wanted
so you use Synology's adapter APIs and just shoved
exactly,
everything that way.
and I needed Synology to be the endpoint because that's the NAS that I always use. It just works great. But what I wanted out of Restic was really good reporting about any files or anything else that was lost along the way.
Yep.
So
the durability report,
the durability, everything that I could get out of logging, I could send it to Grafana or Prometheus or whatever else, and poof, it just worked. So I liked that a lot. Nick Craigwood, thank you for all you do for the community at large. All of us at SUDO Show wanted to make sure that you were recognized in this month's supporter spotlight.
Thank you
Absolutely.
for rclone.
Yes, thank you.
So now we come to our main topic, the Great Cloud Breakup. And I'm sure every CIO, VP of technology has worn a hole in their floor, pacing around, trying to figure out how they're going to handle this big breakup, from the finances to the who, the what, the when, the where, the why.
I think the CTOs would be, if they have a CTO, they're probably wearing the floor to the ground even more, because their job is to figure out the architecture of pulling this off. Like the who,
You're
the what,
right.
and the what, the who, the what, and the why. I think it's probably the easier question. The how is the hard one.
Well, way back when, nobody really cared about reporting or metrics because we'll just say money was infinite, and this was the buzzword of the day, much like AI is now. So
my gosh.
Now that people are assessing budgets a little more, I think one of the questions that's being asked is, why am I paying $5,000 a month for a database that sits at maybe 10% utilization?
My favorite thing is...
Wait, what? Who spends $5,000 a month on a database?
Oh, very simple. You create a VM in some public cloud, you give it a ton of resources, and all it's doing is maybe running a simple MariaDB or Postgres database, because somebody went on AWS and just clicked buttons and said, well, I want to just throw more RAM at it. And
no, this happens all the time. Like,
do you see this a lot? Because I've only seen it a couple of times, and I've scratched my head.
So the problem is, I think Noel and I can both say we've seen this a ton. It's actually
there
a big
companies,
problem.
There are literal companies that make money off of how you properly do cloud spend. They will literally be hired as consultants. They will come in, they will look at what is your utilization across your entire cloud. What are you actually, doing and stuff like that? And how can you actually save money in order to be able to use your public cloud properly? This happens all the time. There's literal businesses that do it. Like,
and my favorite is Corey Quinn from Duckbill, right? Like he's literally, like, I think for many people in the cloud space, he is the face of this insanity, and he owns up to it. He totally like goes in with swagger, and he talks about this, and he gives great talks about how everybody's architectures are absolutely insane for what they're doing, and like his shtick is really going out, talking to people about how you're literally doing it wrong, and what sometimes simple steps can be made to cut these bills by half or more, right? Like, because like it's just really like, I kind of like did the spit take kind of for theatrics, but like seriously, some of the things that Corey's told me, like I would have legit spit taked over. Like there was one where it's like one that I was told that, like, I think it was like one talk or something like that. It was like $1 million of spend that got cut to 1,000.
Oh,
it doesn't surprise me. Like I said, and the other thing is too, what's really interesting is the fact that a lot of companies will, or even like organizations I've worked with, they'll make a deal with the cloud vendors.
Right.
And they'll basically say, I have a committed spend that I need to spend on my, on my cloud bill. And so like, I have literally come in and they're literally like, we need to spend money because we promised that we would. And it's what can we do? What can we do with our committed spend to hit our target? It's like, that is kind of a backwards way of thinking about how this should work.
Counterintuitive to modern business or any business strategy whatsoever.
Oh, no. So here's how it was. So again, previous life, worked in cloud platform sales. I have talked to people like this, and they have explained to me the position of this. The core advantage of this is that they get a fixed line item that they can declare so that the investors don't roast them on a pike. That is the whole reason they do this. And they overbuy on purpose because the penalty of overbuying is you get of not overbuying is overages. And the overage costs in these contracts are asinine. Now, here's the part that everyone always forgets, even these people, when they go and buy these committed spend agreements, the underutilization costs are worse. So if you don't spend enough, you owe that money and a fee on top of it, usually.
What? So, like, I've never heard of this.
It's a double jeopardy kind of thing. Like, the cloud vendor wins in these contracts all the time. This is why, I think, again, have been in the space where I've interacted on the salesy side of cloud software vendors. They are incentivized to jack the prices up because the customers need them to. There is no rational pricing model in most of that stuff because it's entirely based on making sure that the customers don't pay overages or underages, as I just made up that word. But like but they're bad. Like, I read one of those contracts and I'm like, crap, you owe a 25% total contract fee on top of this if you don't spend enough? That's ridiculous. Like, and this contract was measured in 4 to 6 digits per month.
And the other thing to consider too that I've learned, over the years of being in IT is the fact that we are always treated as, well, not always. The successful businesses that integrate IT well are ones that think about IT and basically software development and things like that as an investment rather
as a
than
value center.
As a value center. Yes, rather than basically a cost center, which is what a lot of businesses think about because they're like, well, it costs me a lot of money to run all these servers. Well, yes, but it also costs you a lot of money to buy a bunch of trucks in order to be able to move your product or ship it wherever it is that it needs to go. But you consider that as an investment because that gets your product from A to B. What I'm trying to tell you is that IT provides the same value in the sense that it allows your business to, operate and function in a much more efficient way. It facilitates communication. It facilitates the ability for you to create things, facilitates organization. Like, there's a lot of things that modern IT does that most people don't think about. And so I think what's so fascinating when I started like learning about the cloud and how it functions and everything like that is that, really businesses like one of the bigger reasons that businesses move to the cloud, and especially small businesses, is that they wanted a flat cost, or as flat as possible. It's like they're like, I budget this amount of money to spend on IT. Like, this is all I want to spend, and I think like the thing that can be challenging about running your own infrastructure is that there's variable cost in what can happen because essentially, like, unless you plan for it properly, which people are honestly not super great at planning ahead, unfortunately, and it's just kind of a human nature thing. But I think what's really fascinating is essentially these cloud providers give you a illusion of a flat cost per month that you can spend versus if you've ever been dinged with a server dying basically in your data center or whatever the case may be, it's well, that's a big amount of money I just have to spend to either replace the thing or have support come out and fix it, or I have to send somebody to try to fix and figure out what's wrong with it. So it's kind of one of those things that I think people are starting to realize that this problem of planning ahead and properly allocating resources and doing all the things that they need to do in order to run a modern IT shop, it doesn't matter where the technology lives. It doesn't matter if someone else is even managing it for you, because I've been at a lot of companies too where they hire a bunch of contractors, and the only people that are their IT department or like people who are working on their technology are people that are contractors. They're not even full-time employees that work at the company. Like,
Yeah. Well, so like the other thing to think about here is, so I've been in the space before where for a long time building private clouds and stuff like that. One of the things I think that scares a bunch of companies is that until you reach a certain point, it doesn't become predictable how you
Yep.
life cycle hardware, how you life cycle software, and things like that. Like the place I worked at where I did this, like at the very beginning, it was like, oh, it was super bumpy, like, oh, things are failing, we got to go and emergency replace it. But then you start getting rhythm, and then you can start planning for it. Then you start actually accounting for it and things like that. But also something that's happened in the past 10 years is that the nature of hardware platforms has changed. They now look a lot more like cloud platforms. You have now with UEFI adoption, you have the Redfish system, the Redfish APIs, which allow you to do out of band management in a standardized way across all the different UEFI platforms. Back in the BIOS days, you had to have different tools for ILO and iDRAC and the various IPMI likes and whatever. And now you have standardized protocols for that stuff, which can now be thrown another veneer on top of it to give you a standardized API surface and a fabric. But even if you take all that away, nowadays you have more open-ish hardware. You have open firmware. You have open source BIOS and UEFI implementations and things like that. And one particular company I'd like to highlight about this that's doing a lot of stuff in this space that I think really does change the game about the Great Cloud Breakup is Oxide. So if you go to like oxide.computer, their website talks all about the cloud that you own. And they literally sell you an API driven rack. You install the rack, they give you like a card design, it's standard x86 parts. Everything inside is all the same stuff that you can go buy aftermarket parts for and plug in. But they give you an open source core fabric that is everything is connected to. You have a unified API, you have a unified management interface, and you have a high level model of your architecture. So you don't have to you don't have to internally think about, okay, how do you do the spine of your cloud? Because the spine is this rack. The rack already implements the spine for you. And so you just connect up the spines and connect the racks up and you're done. And this gives you, at the end of the day, the bare metal as a service architecture that you need to implement a higher layer infrastructure. Like, as I was going to say earlier that we alluded to, and I was like, we're going to talk about this now, is OpenStack, right? You roll out OpenStack on this, and OpenStack can use its ironic service. Don't get me about the names of the services. I don't even. But ironic is its bare metal as a service orchestrator. And I'm sure, I don't know if Oxide has ones, but I'm sure that if they don't have one, that they're working on it, that you can plug OpenStack Ironic into Oxide's fabric. And then you now have bare metal as a service orchestrated the same way that you get metal instances in AWS. And all you really have to do is use the measures and the APIs that Oxide gives you to build out your own planning model so that you can provide reasonable elasticity and make the economics work for you. I think this is the piece that frustrate lots of places that try to do this on premises and then they ultimately give up and go to the cloud, is that they don't have this core fabric piece that gives them the necessary information, like building up your own metrics and setting it all up and connecting it to the hardware and connecting it to the stats. That's really difficult stuff. If it's just built into the hardware platform and it exports a standardized interface for you, man, your life is so much easier. And honestly, I'm plugging Oxide super hard here because their software and their firmware is entirely open source.
That's pretty cool.
Yeah, so their whole so it's founded by Brian Cantrell. I can say his name, Brian Cantrill, and he was ex-Sun Microsystems, so he's like super into the network as the computer philosophy that Sun had. He lived through the Sunical, which if you talk to certain people, that phrase is verboten. So I like using the word because it freaks people out. But he lived through the Sunical. He talked about don't anthropomorphize a lawnmower. And he came out on the other end making Oxide, which is a super cool platform for doing this sort of thing. I was fortunate enough. Last year, I was at SUSECon, and I got a hands-on with it with Brian when he had an Oxide rack at SUSECon. We had a wonderful chat about this, and I got super into what he was doing. And I told him, man, like, this is really solid stuff. And I think people should become aware of, like, if you want to be a cloudy provider in your own data center, these are the guys you got to start talking to, because I don't know anyone who is anywhere close to as polished as what these guys are doing. And they're very, very committed to being for the small guys, which makes me very happy as someone who's been for the small guy.
That's really good news. Yeah, I mean, it's kind of one of those things where a lot of businesses, like I will see like even small businesses like spend not an insignificant amount of money, like being in managed services as long as I was, not an insignificant amount of money on, running something like, VMware or anything like that. And like one of the big things that teams just get tired, in the sense of like, running the stuff on premise, and then, VMware, of course, jacking up their costs. Like that's another thing that is causing either people to go to the cloud or to rethink their entire, situation on premises, is the fact that it's like, VMware is jacking up their prices as well. And so it leaves a really big opportunity on the table for, anybody. But it's like trying to find like and especially when we talk about like being for the little guy, for the small businesses, like I'm really glad to see that there's a company that's thinking about this, because
I mean, look at on the Oxide website, they mentioned the fact that they've got direct integrations with SUSE Rancher and Red Hat OpenShift. And Red Hat OpenShift operates on has a bare metal variant. So as does SUSE Rancher with the SUSE Rancher suite. You put those systems on there, you combine that with Oxide, you are 0 to private cloud in one business day. I legit don't know of any other combination of hardware and software that can get you to that in one business day. Well, and I'm saying this as someone who's built one before.
Well, and don't forget either, like the networking piece of this. Networking has always been kind of the outsider when you're trying to integrate these systems, because the skill set for Open vSwitch is so narrow and the hardware is even narrower. And here they say, oh, here's our rack mount switch that's ready to go. You can do whatever you want with it. And that takes away the whole argument of, well, it has to be Cisco, or it has to be Juniper, or it has to be...
Well, it even does block storage. It does elastic block storage. Right. It does self-service scalable networking. It does on-demand virtual machine stuff. I don't know if I would use that part when I would using OpenShift on it, but it's nice that it's built in, right? Like, it is a complete cloud fabric. And this is... I think we'll see more things like this, but so far, the only one that's really spoken to me has been what these guys have been doing at Oxide. Like, they are really on it, and like they've got a podcast and a blog, and like what they talk about on there, it's super, super exciting stuff.
We'll make sure there's a link in the show notes too, so everybody can go check them out.
Even like for a home lab, though, I mean, is this something that you could, in theory, run? Because it looks pretty intense as far as like.
I don't know if they. I mean, it.
I don't know if I put this in a home lab. It's like, if I look at this switch, it's got 32 ports that start at 40 gig. That might be a bit over the top.
That's a bit out of my price range. I can tell you that much for sure with my gigabit Ethernet networking.
One thing, you're right? It would be interesting if Oxide developed like
a mini version of it.
a 1U or a 2U version of it, or like even just a regular small tower version that you could then just home lab it. I don't know how the pricing model would work for it, but it would be very interesting. Might be worth it if any of us have ever a chance to talk to him. Might be worth talking to him about it, or let's just send him the podcast and tell him, hey Brian, let's have Oxide for home labbers in Soho.
Yeah, I mean
that's a great way to get your product in the hands of the people that are going to be making the decisions, because the speed in which business moves sometimes, getting a demo, getting it all through the whole RFP process can take so long that if I can put a project or a product in my data center and give it a try at a small scale without that massive commit, I think that's a much better option. And for a lot of my places that have tiny little closets with a couple switches in them, installing a giant beast like this, you won't even be able to hear yourself think over the amount of fans that are going at full crank all the time.
Sure.
It's a different scale. It's like, I feel like the platforms that are the most successful, and I know we're kind of going a little bit on a tangent here, but like the platforms that are most successful that seem to get in the hands of the most amount of people are the ones that can scale to really small to really big.
Which is often why I don't think Kubernetes tends to work out nearly as much. This is the hot take, spicy hot take.
Here it comes.
Oh boy!
A lot.
Let me go grab a beer real quick. One sec.
Yeah. We're gonna grab your popcorn, folks. We're gonna be here for a minute.
A lot of the Kubernetes platforms, especially the commercial ones, don't have the scaling down to small thing done at all.
No, I disagree with that, and here's why. People have done it. They've put Kubernetes on even little Raspberry Pi devices.
So I'm not saying you can't do Kubernetes on. I'm saying specifically the commercial solutions don't.
No, they won't do that.
Yeah,
and below the commercial solutions, we don't have a standard, because even just me trying to tinker with Kubernetes.
And that's the hot take, right? I think that's the missing piece here. Like, if you want people to become excited about your stuff, you've got to give them a way to small scale up.
A3S is about the closest thing,
but its characteristics are so different from a standard.
I could say the same thing for Minikube or MicroKates, though. Like there's so many different spins on it that, as somebody who would be new to Kubernetes, I remember when I started tinkering with it, I said, there's so many options. I'm here in decision paralysis. Let me ask my friend Neal to come over and let's put OpenShift on one of my servers. But that was so far the other way that day that I didn't even know how to shut off the stupid machine when I didn't want to use it. So,
I mean, at least it worked, as opposed to us trying to play, a classic video game in an emulator. That didn't work out.
That didn't work. It was a very specific platform. That was hard. We failed. The OpenShift thing did work very successfully right out of the box until I tried to use it. But that's Kubernetes in a nutshell. Is you can watch all these videos, you can try all these things out, but there's too many options to where we don't have really a good standard. And that
and a lot of the small scale options, right? Like K3S, MicroKates, and so on, they are explicitly different architectures than the ones that you use the large scale, which means that your experience, I mean, you're going to get some transferable experience. Okay. Let's not say that there isn't any, but
you don't get zero.
You don't get zero, but you don't get enough, right? Your understanding and the characteristics of the platform you're working with are just not going to be similar enough to the ones that you would be rolling out at a larger scale that it becomes very difficult to fully transfer your working expertise. Like, this is in contrast to all the platforms before. For example, you can do a small scale OpenStack. It's painful and it sucks, but you can do it. But it is the same platform as you scale it up. And so all of the knowledge transfers. I hate my life putting together an OpenStack that small, but the knowledge I gain from it actually is fully transferable and scalable to going to 2 nodes, to 6 nodes, to 100 nodes, to 1,000,000 nodes.
I think the challenge with it is it's not even the fact that you can't build a Kubernetes cluster that is more transferable in the sense of how typically individuals run. However, it's kind of one of those things again where it's like, because you're inundated with so many different options and ways in which to be able to run it, like you said, like there's microcates, there's there's so many, like Minikube I've used
And there's
K3S, there's
Kind, yep.
Kind, there's
and they're all different. They all work differently.
Everybody,
and it's nuts.
which is cool. I mean, if we're gonna make a comparison, it's like kind of similar to the way that distributions and Linux, like
distributions don't have this much variation.
It's not as much. Well, I guess if we remember going way back in the day, Linux distributions were a lot different, and there was more standardization that has come over time. Not to say that I think that Kubernetes has had that yet in a lot of ways.
I think the big reason why it hasn't happened in the Kubernetes space is that there is this commercial back pressure to prevent it from happening. In the Linux distribution space, it's been largely community oriented, and that doesn't scale to infinite architectures.
Yeah,
and so there's natural pressure to consolidate the architectures, because that way the mental model for people who are not paid to do this can scale. In the Kubernetes world, it is not normal for people to just be, hey, I love the idea of distributed systems orchestration without state management, and I'm just going to go all in on this. That is not a normal thing people do. That is not even that's not even a thing not normal nerds do. Like, it's just so far out there that, like, the only real drivers have been commercial. And, like, in the commercial space, you want differentiation.
Right.
And so that is the opposite pressure. That's what keeps you from standardizing. That's what keeps you from simplifying and unifying. And
right.
And so that's the problem.
It's a fascinating space. And I think so much, you cannot think about data repatriation or even running any kind of infrastructure these days without having containers come up as or managing containers rather come up as a thing.
It's part of the workload equation.
It's just part of the deal now, because so many if you're thinking about wanting to move people from the cloud back to on premises, they're like, oh yeah, but I know how containers work, and you need to have an actual platform that can run those things. And I think something that is painfully aware to me is the fact that I don't feel like there is there are solutions that exist. I'm not saying that they don't exist. What I'm saying is there's not one that I just point at and I'm like, that's the VMware of this, in the sense of I can run it on a single server or a couple of servers. In VMware's case, it's not really something that you can run. Well, businesses can run ESXi, I guess, just on a single server.
And they do.
I know a lot of businesses that do, and because you can manage it through the web, it's okay. But what you're alluding to in a small business that asks me for this, I'm going to put them in a Proxmox environment, because not because I care about LXC that much. I care about the final solution being I can run containers.
Right.
I can run VMs. I can take backups, and I can centrally manage it if I want to through PDM. And I just have to tell the customer, here's your website and your IP. Oh, and if you want to ingest your your VMware Windows machines, you can. You just click this button and do it. So I think there are some tooling available, kind of half completed here and there.
Yep.
And to your point about OpenStack, I don't think OpenStack ever got to have its day in the spotlight.
No,
because by the time OpenStack, well, here's the thing: by the time OpenStack started to become something really cool, AWS took over.
Yep.
And everybody said, well, I don't need this difficult to use, expensive thing to build OpenStack when I can just click a few buttons on Amazon and my service now works.
And then there was also the changeover to Docker and container native stuff, Elastic Container Service, ECS, which I would never recommend anybody use, even if you decided to be in the cloud. But ECS really stole a lot of thunder for this, because they effectively readapted Docker push into their cloud platform, and that stole the oxygen for OpenStack to be part of the hybrid or on-premises story. I think OpenStack is probably one of the best contenders for the scale from 0 to up to infinity if you really wanted to go down that road, if you're willing to invest in it. But the next best option, like from what I've seen, again, looking at the whole space, and actually sitting down a fair bit to think about this because this is really a hard topic. I think the what the folks at SUSE have done has actually been fairly good. So they have, with their Rancher platform, you can spin up an arbitrary kubelet and then connect it to the Rancher management platform. So you can start from one.
Well, take it a step further. They have their Harvester product,
right? Exactly, which also runs on it runs on a Kubernetes as well, right? Harvester is a VMware interface on top of Kubernetes, or VMware-like, not exactly VMware, but close enough. And because it is also Kubernetes, that means that it can be managed by Rancher. And then so you can start from that one single infrastructure point and go up to tens or hundreds or thousands. On the Red Hat side, which I think is the other major one people would tend to think about, there was a couple of years ago, there was this talk about a MicroShift and single node OpenShift. Yep. I don't know if any of those actually ever went anywhere. I looked at the documentation material.
They do. They exist.
And they seem to exist, but there isn't much material about them.
Yeah, I think the biggest thing is that as a person who works at Red Hat,
well, that's why I'm asking
as a person who has to learn, well, to be successful in what I do, it's beneficial for me to learn all of the products that we sell. And like, I think the thing is what's difficult for me about trying to do something like OpenShift is the fact that the amount of resources that you need to run in order to be able to run single node OpenShift is pretty intense. And like, the more things that you add on to it in regards to, like, if you want to do VMs, then you have to add more resources. And then if you want to do AI, which is a really common thing that, we're also trying to learn, then you need to add even more resources to this single thing. And pretty soon you get to the point where you have a beefy machine that is running in your home lab that you are not spending an insignificant amount of money in order to be able to get. And the way that I looked at it, and it's like, I could spend, like, on older equipment, like, you can run single node OpenShift in a lab, not doing a ton, but you can run things on it, at least from a lab context. But like, you could probably spend like $600 to $800 on these like high powered workstation machines from like probably 5 to 8 years ago. And that would be enough. Like, you'd have spinning Rust in there for your disks and everything like that. But that would give you enough. Like, the main thing that it needs a ton of cores, and it needs a ton of memory. It doesn't need to have the fastest cores ever, but it needs to have a ton of cores. And that's like the really big challenge, is the fact that, like, when you tell somebody, like, all right, in order to be able to run OpenShift, you need to do that. Now, MicroShift's a whole different thing, in the sense that, like, MicroShift is cool in the ways in which that it's stripping down a lot of like you don't get a UI with MicroShift. You just get, a terminal, like,
I assume that
it.
you connect the MicroShift to an OpenShift to see a UI.
No, you do. Well, you could connect it, through ACM. You could probably do advanced cluster management and include MicroShift clusters in there. But like, the thing is with MicroShift is that it's very similar to K3S in the sense that it is a single, node. And like, the other challenges too with these boxes is because of the complexities of Kubernetes and the way that it functions, where you have etcd. If you have an issue with etcd, you have no way to recover realistically, because most people, the way that they run etcd is that they run it highly available, so it's able to recover, when you have those other nodes. But if you have a single node and you have a problem with etcd, you're toast.
I know. I ran single node OpenShift for years. I know what happens when etcd can't get raft consensus with itself. It is not a happy place.
And so it's kind of one of those things that I think that, like, Red Hat, like, we do say, yes, you can run OpenShift and you can run it on, like, hardware, but it's not an insignificant cost. Like, even for me, like, I'll probably end up using, hopefully like some money that I can save up to be able to start actually having a lab with OpenShift. But it's kind of one of those things again where it's a challenge. Like, and I really, that is like something that is so painfully aware, specifically in the small business sector. If you're talking about larger businesses where they're more thinking about data repatriation in the sense of like, like the interesting thing to me is like it depends on your situation. Like
Sure.
you could be whole hog like, oh yeah, we moved everything to the cloud and the cloud is the future and that's the way things are, and then you're like, oh god, it's expensive the way that we
Yeah.
did this. And then you could have the hybrid approach, which is what a lot of businesses did, where it's like either like, and I want to be nice to businesses because I think like it's really challenging to run, a larger enterprise, but
it's a tough problem, right?
You end up in a situation where you're like, our intention was to move everything to the cloud. However, we've decided on a hybrid cloud strategy because we couldn't move these things in an easy way in order to be able to do or fast enough. Yeah, like
or people didn't know how the architecture worked, and that means that they couldn't finish figuring out how to do the move
or secure it.
Yeah.
Yep. That's also a challenge.
There's a lot of different issues there. Like, but basically I want to come back to saying like any kind of repatriation, whether it's large or small scale, means it's going to be a large upfront CapEx investment. Capital expenditure, purchasing hardware, purchasing resources, getting contracts in place, getting services and support. Those are all things you're just gonna have to frankly bite the bullet and deal with. If you're in a space or in a size where something like Oxide and OpenShift or Oxide and Rancher Suite can make sense as in like commercial pair, that's a really good option. Like I saw it in person and I was blown away. That is a very easy pathway, and that gives you an easy path for repatriating virtual machines, repatriating object and block storage, repatriating network configuration, which by the way was not a thing I ever conceived was a thing I'd have to think about. But they have tooling for being able to just clone networking architectures. That's immense. But when you're smaller, I guess look at what you can do with the standards that exist. Like it's still not all bad. You can get computers from a few years ago if they're all UEFI and they have Redfish support for their BMC APIs. Then you can use something like open source Rancher, OpenStack, or OKD, and you can roll out a private cloud yourself for. I mean, it's still not chump change, but it's not exceedingly expensive either.
So here's how we're going to do this on the cheap.
God.
Noel, I have an action item for you.
Oh, okay. What do you got for me?
I think that you are capable with your expertise, skills, technical prowess, connections of repatriating all of AWS into a single MicroShift cluster.
Yeah.
All of AWS. Everything in all of it. The whole AWS.
All of it. I'm not going to use Oxide for any of this.
No,
just a single MicroShift cluster.
Since you need some home lab, I will ship you 3 Raspberry Pi 4Bs.
Oh, good. Good.
I'm pretty sure you got this under control. Each one has a gigabit NIC. That should be more than enough. And then if you can, I'm sure you have the time to do this too, but I'm sure you can compress all of AWS down into a single 100 terabyte SSD with some recursive tarballing and maybe some dark magic with compression.
Oh, but the dark magic is a necessity at this point. Yep. We're in there.
All right, so dark magic can translate into dark rum. That may be the dark magic you need to finish this very doable and very accomplishable project by the time that our next show records. So we'll check in with you then to see how your action is gone.
There's going to be plenty of blood, sweat, and tears. I'll try and see if I can email Jeff Geerling because I know he's like really, really good with Raspberry Pi projects. So I think he can probably help with this too.
I think Jeff would be more than happy to offer you some very sound advice. But before we go, I wanted to give everybody this month's quick fix, which is NetHogs or NetHogs. I prefer NetHogs. But a lot of people are just going to look at their cloud dashboard. They're not really going to pay attention to what's actually eating up all your bandwidth. So this is kind of where NetHogs comes in. So it'll show you exactly which processes are talking to the outside world in real time. You might happen to have a Chatty service you didn't know about, or maybe spun up the wrong way or is buggy, that's costing you a fortune in egress fees if you moved the database but left the app in the cloud. So make sure that you know what's going on with your traffic before you just simply move it. So some ways that you can use this with some toggles. So let me back up. This is like top, but not. So top is great for seeing processes. NetHogs is going to show you kind of the same thing, but at an application layer. So it's going to give you real-time data. It's continuously updated. It's interactive. It's easy to read. It's text-based and just outputs using end curses. So all things that we're familiar with. No modules, nothing crazy. And some of the interactive controls that you can use are M. So toggle, TAC M or hyphen M, whatever you want to say. We'll toggle between display total cumulative or current, so per second bandwidth. And a lot of network administrators want to see that. They want to see the snapshot and they want to see the whole thing over a period of time. You could also just use TAC R to show received traffic, TAC S for sent traffic, and of course, Q to quit NetHogs. You can also pick the device. So most people have dedicated NICs for storage or applications or what have you. SUDO NetHogs device for your Ethernet device, or you could put it into trace mode by TAC T. Very easy to install. apt-get install NetHogs, DNF install, or yum install NetHogs, or even Pacman TAC S NetHogs if you are an Arch-based user.
Or just add it to your NixOS config like Neal does, and then we're good.
Yes, you can also add it to your NixOS config the way that Neal does, or as Neal will probably do, he'll create an emerge for it on his Gentoo server.
Oh, yeah, that's right. I forgot how many Gentoo systems he also manages these days, too.
Yep, using OpenRC because he hates Systemd, even though he has the shirt.
You are bringing up particularly cursed memories, Bill.
I know. I'm the one that had to live through it with the whole Gentoo thing.
I was on the other end of that.
You were on the other end of it. But I was the one being marched to the gallows with a pitchfork behind me. So
someday we will tell this story. It will be very entertaining. Probably a pseudo war stories thing.
Oh, yeah. We definitely need to have an episode on war stories. I think that could be really fun.
We are going to absolutely have an episode of war stories, but I'm actually thinking maybe our next episode is the $50,000 typo.
Ooh.
So we go and explore the $50,000 typos that each of us have done. Mine actually ties a little bit into what we've talked about today, but I'm sure the three of us have had the $50,000 typo. So we will take one for the team, the SUDO team, and talk about what our $50,000 typos were. And maybe there's some members in our audience that have also made the same mistakes or want to contribute some of their own $50,000 typos on our Matrix channel or our Discord channel, some of the ways that you can find us.
That would be so fun because we're all human and we do this and it sucks.
It's brutal. It's a lesson we all learn at some point, and we can laugh about it now. But my goal would be that some sysadmin says, "Oh my God, what's just happened?" Hey, I think some idiots on a podcast at one point talked about that. Let me go look that up. And there will be our 3 mugshots in the Hall of Shame of things that we have done. But this does bring us to the end of another SUDO Show episode. We hope today's episode gave you that quick win or some insight into data repatriation to help bridge the gap between your business goals and your Linux stack. But before you leave, there are 3 ways in which you can help us keep the lights on and grow the show. Well, we'll say 3.5. I'll get to that. On YouTube, if you're watching us there, please hit that like button, subscribe, and ring the notification bell, ding, ding, ding. It's the best way to make sure you never miss a deep dive. If you are on the go like me, constantly driving between places, and you prefer the audio version, make sure you follow us in your favorite podcast application so that the latest episode is always ready for your morning or evening commute. We also have a shop where you can buy SUDO Show swag like this amazing t-shirt. I also have the barbecue apron. There's many things that you can purchase from there. Thanks to our friends over at Tux Digital. You can head over to tuxdigital.com/store and click on all the amazing SUDO swag that you've always wanted. Now for the 3.5. We are going to get a Patreon up. What we provide as part of that patronage, we're still kind of ironing that out, but we do know that one of those features and functions and amazing benefits of being a patron will be hanging out with us maybe on some live streams, but also having access to those webinars we've talked about. So we'll put something a little bit more formal together, hopefully before next episode, of what the patronage guarantees you. It also, again, helps us offset the show. So for all of you that listen, support, subscribe, like, hang out with us, thank you again. We couldn't do it without you. We do it because of you. We enjoy it very much. You can find all the links for what we've talked about today on our website, www.sudo.show. Thanks for joining us again here in SUDO Show, where business meets Linux. We'll see you in the next one.
Bye-bye.